right, so what we talked about in the last one is what is an atom made up of, right? And we decided that an atom was made up of protons, neutrons, and electrons. But what we didn't talk about is which one of those defines an atom? Is it all of them? I mean, is it just the mixture of protons, neutrons, and electrons that says this one's calcium, this one's carbon? Or is there another way to it? We talked about how they're organized, a small nucleus containing, what is it? Yeah, the protons and the neutrons, and the electrons really far out, like really, 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 really far out there. Okay? So what we're going to talk about in this one is what makes an atom itself. How do we know an atom from one element versus an atom from another element? And it turns out, again, long story short, what we figured out is that it's the number of protons that determines an atom. So if we want to know whether we have carbon, nitrogen, hydrogen, or whatever like that, the only thing we have to look at is the number of protons. Okay? How do we know? Well, if we start from the beginning of the periodic table, so let's go to the top left here, and we look at hydrogen up there. It turns out hydrogen is the first element on the periodic table for a good reason, because it has a single proton. So hydrogen has a single proton. So hydrogen is one proton. Okay? And it turns out any element with only one proton is going to be hydrogen. Doesn't matter what else you put on there, neutrons and electrons, you're still going to have hydrogen. Now those neutrons and electrons, those are going to do things. They're going to be important coming up, but they're not what defines the atom. And if we go to the next element on the periodic table, if you look at your periodic table, by the way, in the class it's always a good idea to have a periodic table on hand. Print one out, have it available for yourself. It's got 2 protons. And anything that has 2 protons is always going to be helium. Right? If you've got 1 proton, you're hydrogen. If you have 2 protons, you're helium. So let's go back to our periodic table. And if you look at the periodic table, it might be a little hard to see on this one. Like you look at hydrogen, the top left of the periodic table, there's a little 1 in the top left. If you look at helium, which is on the right-hand side of the periodic table, there's a little 2 in the top left. What is that telling us? Well, it turns out those numbers in the top left are telling us how many protons are in that element. Or conversely, if we know how many protons we have, we can look up our element. So again, have a periodic table on hand. Try to find which element has 6 protons. So you go along the periodic table, hydrogen, helium, lithium, beryllium, right? Lithium has 3, beryllium has 4, boron has 5, and carbon has 6. So anytime you've got 6 protons, you know you've got yourself a carbon atom. Again, we'll find out we can have more neutrons, less neutrons, more electrons, less electrons. It's still carbon. And that's what distinguishes one type of atom from another type of atom. So let's just do one more. Let's look down in that yellow section. The first thing in the yellow section is an SC, which stands for scandium. How many protons does it have? Hopefully you came up with the number 21. It's got 21 protons. So that's what we use the periodic table for. Okay? So it turns out it's really, really important to know how many protons there are in whatever you're doing, because it tells you how many atoms you have. Again, if you have 2 protons, you've got your helium. If you've got 6 protons, you've got your calcium. So the counting is very important. We need to keep track of the number of protons. And if you look at my words here, I said need to keep track of the number of neutrons because that's important as well. Well, if the neutrons don't matter for identity, why does it matter? Well, because it matters for how big and heavy the atom is. So if you have something, right, the neutrons weighed about the same as the protons. We said they're about the same size. So let's say we have carbon, 6 protons. Let's say we had one with 6 neutrons. It's going to weigh a certain amount. But if we start adding neutrons, 7 neutrons, 8 neutrons, it's going to get heavier. And how heavy something is does make a lot of difference for how it works. Okay? So it doesn't change it from carbon, but it does change its mass. So it's important to keep track of that. Turns out it's also really important to keep track of electrons, and we'll get to why later on in the class, but we're also going to need to keep track of electrons. So how do we know? Okay? Well, we saw that protons were given on the periodic table, and we call that atomic number. So the number of protons is the atomic number, which is sometimes abbreviated Z. So I'm going to use carbon as an example here. we're going to write down its elemental symbol, C. Remember, there's no letters after that. Some things just have one letter. So carbon right there is C. Now, in order to keep track of things, we have a kind of standard notation that we use. And the standard notation is to always put the number of protons in the lower left corner. And so we're going to write a 6 down there in the lower left corner to say that carbon has 6 protons. Now, sometimes people will leave that off because you can always get it from the periodic table to know that carbon has 6 protons, but sometimes people will put it there. Now, how many electrons do we have? Well, it turns out the electrons in what we call a neutral atom, and we'll discuss what that means later on in the class, same number as the protons. If you remember, protons were positive, electrons were negative. Nature loves balance. And so the number of protons and the number of electrons are going to be equal. We're not going to put that anywhere in these symbols. Okay? If we have an equal number of electrons, nothing appears. We'll see what happens when we have an unequal number later on. Now, it turns out, even though we need to know the number of neutrons, nobody tells you that directly. Oh, what a pain. They only give you that number indirectly. And they give you that by putting a number in the top left here, which is called the mass number. Now, what is the mass number? The mass number is the number of protons plus the number of neutrons. And so I have a mass number of 12. That's there. We know that there's 6 protons because we already said that all carbon atoms have 6 protons. And so what we're just trying to do is figure out here, how many neutrons do we have? Simple, right? 12 equals 6 plus what? And we get that the number of neutrons is just 12 minus 6, or 6. So in this particular case, for the symbol I wrote down, I say this is carbon. It's got a 12 up in the top left. It's got a 6 in the lower left. And that means it has 6 protons and 6 neutrons. Now, that's kind of hard to say that symbol out loud with the 12 in the top left and the 6 in the bottom left. So we have a way of saying this. And if you were to try to say this out loud, you just say this is carbon 12. We put a dash there when we write it, but we don't say the dash. So carbon 12, and that is a dash, not an underscore. Okay? So this is carbon 12. Now, how come we don't tell you in this that there's 6 protons? Because like I said, we can figure that information out in other ways. So we don't need that. We can look at a periodic table. Alrighty, so what if I had a different element on the periodic table? So let's go down and say pick calcium. Find calcium on the periodic table. It's an alkaline earth metal. Do you remember those ones in the second group? And it's number 20. So we're going to take calcium and write that down there. And it's number 20. Where do I put the 20? On the top or on the bottom? Right, number of protons goes on the bottom. And then I might want to know how many neutrons are in here. But again, nobody tells me directly. So I'm going to write 42 here. And I'm just making that number up just for an example. We'll figure out ways of how do you know that. Somebody has to tell you that information. Okay, so how many neutrons are in this example? Well, we do the same math up there. I'm not going to do all the steps, but we end up with basically our mass number minus our atomic number. And we figure out that that's 22 neutrons in this guy. Now I've got to turn myself off here. 22 neutrons in this guy because 42 minus 20 is 22. Now another similar type of problem is what would be the elemental symbol for, let's say, nitrogen with 8 neutrons. Okay, so how do we do that? Our periodic table is always our friend. So let's go over to the periodic table, and we're going to find nitrogen on the periodic table. Now, you can't read this one very well, but hopefully you have a paper one in front of you. If you look along the second row of the periodic table, you see that N in the middle there, and that is nitrogen. So we're going to go back, and now we've got nitrogen there. And we want the elemental symbol for nitrogen with 8 neutrons. Well, we need to know how many protons it has. We go back to our periodic table. Nitrogen up in the middle there has a 7 in its top left. And by the way, that top left, some periodic tables put it in different places. It's whatever the whole number is. Okay, it's not the decimal number that you're looking for. Okay, so 7 protons, where does that go, top or bottom? You're right, it goes on the bottom. Now, I've got 8 neutrons, so it's tempting just to put an 8 up there, but that is not correct. Because remember, what goes up there is not the number of neutrons, but the number of protons plus the number of neutrons. And we know we have 7 protons And we know we have 8 neutrons because someone told us, for a total of 15. So I'm going to put a 15 up there. And how would we say that out loud? We'd call it nitrogen 15. All right. So that's what we do when we're writing elemental symbols. We use protons and neutrons as our mass number up on top. And we use our atomic number on the bottom. Now, why do we keep track of the neutrons? Can't we just say, well, you know, it's carbon, it's got this many neutrons? Well, the answer is no. Because it turns out that most elements on the periodic table don't just have one type of atom. They have several. They all have the same number of protons, right? Because we wouldn't have bromine if we didn't have 35 protons. But it turns out there's different ways of making bromine with different numbers of neutrons. So let's just do a quick example here just to refresh ourselves. In this top one, how many neutrons would I have? 35? 79? No, right? 35 is the number of protons. This one is the number of protons plus the number of neutrons. And so we've got 79 is number of protons is 35 plus the number of neutrons. So the number of neutrons is 79 minus 35, which is just equal to 44 neutrons. Right, and we call that element bromine 79. All right, I've got 2 of them down here. Why do I have 2 of them? Because like I said, for most elements on the periodic table, there's many different ways to form it. How do you know which one to form? Someone will always tell you. Okay, this is not something you need to know off the top of your head. You will always be given information that will allow you to know which one you're talking about. So let's look at the one on the left here. We've got 127, 53, and I. So go to your handy dandy periodic table, look at that. That's iodine. Okay. And how many protons in iodine? Right, 53, right? Number of protons is 53. How about the number of neutrons? Well, number of neutrons, I'm going to skip a few steps here because we've done this a few times now, is going to be 127 minus 53, which is going to be 74 neutrons. Okay. But it turns out you can also make iodine 126, which is going to have, what, 73 neutrons. Right. And again, you'll always be given that information. So we have iodine 127 on the left, we have iodine 126 on the right. 2 different forms, both of iodine, and we call these isotopes. And what are isotopes? They are the same element with different numbers of neutrons. Okay, so on the left we noticed we had 74 neutrons, on the right we had 73 neutrons, so we ended up with an isotope. Same element, different number of neutrons. Alrighty, so a couple examples for you to try. First one, how many protons are in potassium 39? So take a moment and try to answer that one. Alrighty, what did you come up with? Well, we need to go over to our handy dandy periodic table and find potassium. Potassium is one of those odd ones. It's K. It's got 19 protons. Okay. And, oh wait, that's what the question asked for. So right, we just get that straight off the periodic table. That K has a 19 on it, and so we get 19 protons, and that is our answer to that question. So might have tricked you because we were doing neutron, 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 then we did proton. That was kind of the point. You just got to pay attention to the question, and we're finding number of protons there. All right, what do we do next? We do how many neutrons are in zinc 65. All right, go over, find your handy dandy periodic table, and see if you can come up with the answer to that. Alrighty, zinc, if you look on your periodic table, is Zn. Did you find Zn on the periodic table? Let's go looking. Okay, we see Zn over there. It's the top right of the yellow ones, and it's got a 30 on it. So we're going to put a 30 down here. We always put the atomic number on the lower part. We're going to put a 65 up here. And the nice thing is, if you look at this, it's kind of set up for you like a subtraction problem already. We take 65 minus 30, we get 35 as our number of neutrons, and our answer right there is 35. All right, so that's how we count protons, neutrons, and electrons. The periodic table tells us protons. Neutrons, we have to be given that information somehow, either directly or by given the mass number. And electrons, for now, is equal to the number of protons. So this zinc one here that we have an example of, since it has 30 protons, has 30 electrons. Thank you so much.